Hey everybody, welcome to Data Engineers Lunch number 16. Today's topic is for Data Engineers Lunch is Introduction to Awk for Data Engineering by our very own Arpan Patel. Arpan's a junior engineer here at Anant and growing beyond that these days. I'm your organizer for this meetup, looking for collaborators to help co-organize. And also, if anybody's interested in talking about anything related to data engineering, data processing, just whatever you've done recently, or if you want to learn something and play around with it and show it off, more than welcome to have you do that. Data Community DC is the larger community in which we are just one of the many groups. We're a diverse community looking for people of all backgrounds to come and speak on data. Data Community DC includes groups like Data Science DC, Data Visualization, Data Education, Full Stack, Data Science. What do we cover here? What we cover here is the get your shit together solution to the get your shit together problem, which is that in order to do anything substantial with information, we have to bring it together, clean it, process it, maybe engineer features, and eventually to produce data products that get used by further processes such as exploration, dashboards, machine learning, so on and so forth. So as you can imagine, there's like near infinite number of topics that we could talk about, but we talk about data, how to process data. Normally at this time, ask people to introduce themselves who are new to this group. Just say hi and what you work on and what you might want to learn. Anybody want to just say hi?
I could start. My name's Dimitri. This is my first time joining this group. I've been meaning to join for a while. I saw that you guys had an Airflow presentation recently, which I was sad to miss. But yeah, I'm also I work as a data engineer at Capital One. I'm also a co-organizer and co-host of some of the DC Python meetups. Most of those have gone virtual now, but for 2018, 2019, I hosted the Beginners Learning Lab through DC Python, as well as some of the Project Night workshops. So this year, I'm just looking to get more involved in the data engineering and Python meetup community, and going to be hosting some events in April and May through DC Python. So I'm also looking for collaborators and speakers. So I thought I'd join and check out what's going on.
Great. Yeah, and actually, Dimitri, we'll ask for announcements, and you can just post your information of your events on the chat here, and let everybody know. That's great. It's
Sure.
awesome to get folks here involved. Well, thanks for joining us. And yeah, we're covering a variety of topics, and I think we're going to come back to Airflow again. There's about 1,000 different things you can do with Airflow that I think everybody wants to learn. So awesome. Cool. Anybody else want to just say hi? Wow, we're getting quite a show.
Hello. Yeah, I can chime in. Yeah. So hello, everyone. My name is Flora. I'm essentially like a data engineer, data dev for the Federal Reserve. I'm introducing myself to this community to see what else I can be a part of, and I'm interested to learn everything, essentially.
Great. Welcome. You're in the right place. Yeah, and if there's anything that you know of, as I mentioned to folks here before, if there's anything that you have done that even if you don't think is that fascinating, there's probably somebody who's relatively new to data that wants to learn it. So excellent. Glad you're here. Anybody else want to just say hi? Just quick introduction, what you do, what you want to learn, and maybe what you could present on. All right. Well, I'm not going to pull teeth. And we have so many new people that if I went through everybody, we'd be here forever. All right, to continue, group rules. If you have a question, just ask it, be polite. Some speakers would like you to keep the questions until the very end. Most speakers, you can ask the question in chat, and if they acknowledge it, you're good. Otherwise, we will have some time at the very end for Q&A. You can use this as an opportunity to, just share what you know, right? Even if it's not a question, it's in the form of an elaboration of what the speaker's saying. You can put that in the chat or just chime in. Our company, Anant, we help our clients and professionals build very large-scale platforms that help run the world using real-time data technologies like Cassandra, Spark, and Kafka. DataStax is a partner and a sponsor of this group, as well as Cassandra Lunch DC, which is every Wednesday. GW has been a great partner of Data Community DC, as well as this group for a long time, hoping that when we get back to events, maybe, I don't know, next year, we'll have a space in their building. We also have some local sponsors in Chicago and DC, as well as our institutional organizational sponsor that make Capital One, for example, that make Data Community DC events possible. There is a Data Week DC that's going to have it happening probably between September and October, or maybe August and September, I'm not sure. But these organizations help make that happen. I actually am too busy to volunteer, so they're actually looking for volunteers if you want to collaborate with Data Community DC on Data Week DC that's coming up later this year. Anyone want to announce anything such as people looking to hire, people looking for work, events, meetups, classes, courses? Feel free to just unmute yourself and say hi. All right, I don't see anybody. Dimitri, if you want to just post your stuff on the chat, that'd be great.
Sure. Yeah, I already sort of mentioned it, but the DC Python meetup, right now, all events are virtual, of course. There is a main monthly meetup that is the last Saturday of every month. And there is an evening of Python coding meetup, which is more of a co-working space. It's similar to what we used to call a project night, where you show up, there's pizza and drinks, and everyone introduces themselves and what they're working on. And say you're working on a Flask app and you're a beginner and somebody there is a Flask expert, you can break off into a breakout room and collaborate on that project, and they can help you debug. So that's sort of the spirit of the evening of Python coding, where it'll be a little bit more collaborative, but there are also presenters as well. So yeah, check that out. And like I said, I am looking for presenters for, it'll be the May meetup. So the May 29th event, I think. So if anyone is interested or has ideas, please feel free to reach out to me. Just DM me on Meetup.
Thank you. Appreciate that, Dimitri. And I just want to highlight a few other events that are happening. So Data Community DC has a few events happening around deep learning and Mathematica at UVA and Howard University. Data Science DC has something tomorrow about enterprise AI. Not sure which technology Snorkel AI is the technology they're going to talk about. And as Dimitri mentioned, there's a few meetups that are coming up for Python DC as well. Excellent. Anyone else? If not, we have some events coming up from our group here. Next week, we're going to be talking about, are these all Cassandra lunches? Okay, well, there's some Cassandra stuff that's happening in the next few weeks. Well, Wednesday in the next few weeks. Today, obviously, we're talking about awk. And go back here. our events are, for now, the Data Wranglers DC events are all just the monthly, the weekly Monday slot, noon to 1 p.m. Eastern Standard Time. We have a speaker right now in the queue for talking about Prometheus and Grafana and how it's useful in data engineering and data operations. If you have something that you'd like to talk about, just direct message me in Zoom here, or it will direct message me in Meetup, and I'll be happy to put you in the queue. Awesome. Yes, thank you, Lena. If you could just drop that in here in the chat, that'd be great. Very cool. All right, and without further ado, I'm going to go ahead and hand it over to our speaker, Arpan. Arpan, ready whenever you are.
Alrighty, thank you. I will go ahead and share my screen. Make sure this was the right one. Can everyone see my slide deck?
Yep.
Perfect. Okay. So today, as Rahul mentioned again, we're going to be covering awk and how we can use it for data processing, data cleaning, et cetera, just in general for data transformations with data engineering. If you have any input or if you ask any questions, go ahead and speak up. I'm not very particular about it because in my philosophy, it's if the more you know, the more everyone will know. So if you have anything you want to say or add, go ahead and speak up. But yeah, let's go ahead and get started. So awk is a domain-specific language designed for text processing, and is typically used for data extraction and for reporting. So typically it works by like you look for a pattern, or you can make it more specific depending on how you want to operate with it. And it's very good for parsing and manipulating tabular data. So in our demo portion, the presentation will actually be manipulating CSV data. So you can show you how, if you've not worked with awk or if you're not familiar with it, you'll get a little short introduction of how it works. So essentially, under the hood, it operates line by line, and it iterates through a file or an input. So the nice thing about like awk or something like sed, which I've also presented on, I think last month, these things can be used in pipes. So you can take something from one source and just do continuous manipulations on it with different command line tools and then put it somewhere else, just simplifying and making the process even faster. So typically when you run awk, you specify a program. So that's like the base unit. And that program tells awk what to do. And the program consists of a set or a series of rules. And rules consist of a pattern. So typically if you're looking for a specific pattern you want to operate on, like sed does, you could use like a regex or something of the sort. And then it's an action followed after that. And those are typically contained within curly braces, and we'll take a look at that in the demo portion. And the basic syntax is awk, and then flag any options if you want to add something. We'll use a couple different options in the demo, and we'll talk through it. And then when you define your program, it's contained within single quotes. If you're doing it via a single line, if you're doing it via a script, you don't need the quotes, and we'll show you that when we get to the demo. And then if you have an input file, you would have the input file at the end. You could have multiple, or if you're using a pipe and your stdin is different from an input file, you just put that as a part of the pipe. And GNU provides very thorough documentation. So that's also linked in the slide deck. And I used it when I was putting together this presentation. So if you're new to awk, if you want to learn it, I definitely recommend looking at it because it's pretty thorough. And yeah, we'll go ahead and move into the demo. I will send this link in the chat. So if you just want to like go through the GitHub repo as we're going along, we're going to be doing this in Gitpod, just so that you don't need to download anything to your local computer. And Gitpod already has awk within its Linux terminal upon startup. And so what we'll cover in the demo is basic printing, a couple built-in variables, how to use scripts and UDFs, how to write files. So from a pipe, output the output to a file. And then we'll cover like a real world application where we could use awk. And then we'll also show you an extended example where we can use odd and sec together, awk and sed together to further do additional data manipulation. So I've already spun up the Gitpod container. Can everyone see it?
Yep, we can see it.
Okay, cool. All right, so I will have my GitHub repository on my second screen, so that way I can just copy and paste and go through. So essentially, we are going to, or actually starting with, so there's a couple different versions of awk that are out there. So the one we're using specifically is just the GNU awk. So if you want to replicate it perfectly on your local machine, we're using version 5.0.1. So I'm just going to expand this real quick. So we are going to start with basic printing. So we have this txt file, which is just the Thundercats theme song. So if you want to print within your program section, our action is print. So when we say awk within our program, within the single quotes, our action within the curly braces, we don't have a pattern, so we're not looking for anything. So we just say print. And then that will print out the text file. So it'll go read line by line and then print that out. And then additionally, as I mentioned, we can do the same thing, but instead of using an input file, we can do it as a std in from a pipe. So we say, take the output of the cat and then pipe that into awk. So we did the same exact thing, minus using an actual input file. So now we'll talk a little bit more about fields. So when awk reads an input record, it automatically parses or separates a record into chunks called fields. And by default, these fields are separated by a white space. So if you think about it in a sentence, each word separated by a white space is a field. So like the first word would be field 1, second word would be field 2. So if you want to use the field designation, it's designated by a $sign. So when we say awk, print $0, that is still the same thing as print all. And so it still comes back, it prints out the entire thing. But if we only want to print out the first word, we say $1, and that will indicate print out the first field of each line in the record. So we see the first word. Also, if you notice that these commas are included in the first field because they are still within that first pattern that are before the white space that designates a field separation. So we'll just keep that in mind as we move along. But if you're working with text files and you're doing some kind of manipulation or transformation on it, that might be something that comes into play where you have to account for. You could potentially use sed for that as well, but you can still do G subs using awk. Okay. Mark has a question. Is there a way to choose what character designates the field? I'm not entirely sure.
You mean like a delimiter?
I think he means by like print $1. So is there a way to change the $sign symbol to something else?
Well, that and also as a delimiter to change it from a space to something that I define to make it more controllable.
Yes, you can change the delimiter. I don't know about the actual symbol itself.
Gotcha. Okay. Thank you.
Yeah. And we'll talk about that, especially with the delimiter, because when we're working with tabular data, so if we have a TSV, CSV, we need to say, don't look for white spaces, look for commas as the field separator. And we'll cover that when we get to a little further down in the demo. But yeah, moving back. So when you're using field designators, you can also print them or use them in any specific order. So you don't have to say print 1, 2, 3. You can say print 5, print 3. And so that's what we're doing here. And so if you notice that for line one has 5 words. So there are 5 fields. But say if a single line does not have a 5, it would just print out a blank space for it, but it still picks up field number 3. But yeah, that's just some basic printing with some field variables. Now we'll talk about other built-in variables that awk has that you'll often see. So a couple that we'll be using are nr and nf. So nr keeps a current count of the number of input records read so far. It starts at 0, but it's never automatically reset to 0. So nr is different from fnr. So FNR updates depending on, say, if you're like working from pipe to pipe or file to file. When you change from file 1 to file 2, the FNR resets to 0, but NR continues incrementing. So if you're using some kind of loop where you need to watch for NR and FR, and you need to designate, okay, when this change happens, do something else, that's something that you need to keep in mind. But generally, NR is just for keeping count and numbering lines. But FNR, especially if you're using multiple files, it can come into play. So what we're going to do with this line here is we're saying print NR. So that will print the line number or the number of record, the record number, and print everything. Remember, $0 means everything. So we see record one, Thundercats, the whole line, 2, 3, etc. And if we want to print, if we want to print a specific range, we can set we can set NR equal to a number or greater than or less than to say only print this record number or print records between these record numbers. So in this one, we're setting our pattern as NR equals 1, right? Because in your program, within the single quotes, you have a pattern, then your action. So we're saying in the pattern, if the record number is 1, print it. And so that's what it did. It printed the first line of lyrics. In this one, we're saying if the record number is greater than 1, print it. So it's printed everything except line 1. And then if we're going to do a range, it's the same thing. So print everything between record numbers 4 and 9, and then that'll print out the theme song. So now we can also use NF. So NF is used a lot, especially in UDFs. But essentially NFs is the number of fields in the current input record. And the last field of the input record can be designated by $NF. So like the end of a line, that field number. And then the second to last could be $NF -1. Third to last would be $NF -2. So you can use it kind of in a more, what's the word for it? Dynamic fashion. If you want to print out specific fields, if you already know what you're working with. But essentially, what we're doing in this line is we're saying print the number of fields for everything. So we're saying the first line has 5 fields, 3 fields, 6 fields, et cetera, et cetera, et cetera, which makes sense. So say if we want to print the line number and the word count, how can we do that with NR and NF? So we can say print, and then if you want to have like text within your program, you can, or within your action, you can just include it with single quotes, and generically a space translates pretty well over. But if you want to have a tab, you would put that in single quote or in double quotes, and then \T, and then that will have a bigger indent between whatever you're printing. So what we're saying here is take the say line and then use the line number has a and then word count of, and then use the NF to variable. So line 1 has a word count of 5. So there's 5 fields. Line 2 has a word count of 3. So that matches up. That's just simple couple built-in variables. We'll also use a few other built-in variables like OFS when we get to the more real-world application of how we can use awk. But essentially, these are some common built-in variables that you'll see. So the $ indicator indicating a specific field, or NF and NR, FNR, etc. So currently, we've only really used one pattern, and that's one set of patterns. So that's when we were saying NR equals 1. This will actually use like a text pattern to look for something. So in this lyrics.txt file, if we look for the pattern of lowercase thunder, we're saying print the first word of each line. So that's worked, right? So if we look for lowercase thunder, we only see it in the chorus. And we're saying print $1, so field 1, so it's correctly printed the first field. Again, remember, the default white space, because we haven't set it, the default field separator is a white space. So it includes the comma as a part of field 1. But essentially, yeah, that's how you can use a pattern, look for a pattern, and then do some kind of action on top of it. And then if we want to do multi-patterns, there's 2 ways, or there's a couple more ways to do everything we're doing. But this is just so you can get a basic understanding if you haven't really worked with awk before. So in this method, we're using a OR operator. So we're saying, look for the pattern thunder, and then we use the pipe symbol, or look for the pattern magic, and then print that entire line. So what we see here is the same thing we just did before worked correctly, but because we have this OR symbol, we also got back the pattern that got matched, or the line that matched the pattern that had magic in it. However, if we want to use an AND, we would do the first pattern, and then we would do an and then the second pattern, then the action on it. So we're saying, look for lines that have the pattern uppercase Thundercats and lowercase loose, and then print that line. So when you look at that, there's only 2 lines that have it. So there's line 4 and line 2, because both of those patterns were found in those lines, and so they match the conditions.
Or those are just regular expressions, right? Between the 2 ands.
Yeah. And yeah, so obviously these text expressions can be changed for if you're using actual regex on more complicated pattern searching. But yeah, so it's pretty much that, the concept of it. Yeah. So now we'll take a look at scripts and also UDFs. So the really nice thing about awk is it's very robust in terms that you can create functions and do pretty much a lot based on your input data using UDFs. So typical syntax for awk when you're using a script file is flag lowercase f, and then the file name, and then whatever input, or if you're using a pipe, you don't need the input file. So what we're doing here is we're saying awk lowercase f, so designating that we're using a script file, our file, which is called script.awk, and then our input file. So if we look at script.awk, we have this little for loop, or we've actually defined a function called substitute. So within this substitute, we're running a for loop that will go through each line using the field indicator as I. If it matches Thundercats, uppercase, change I to uppercase Lightning Cats. Else if, so another condition. If it's Thundercats exclamation mark, because again, remember, we hadn't touched the default separator yet, so we're still working with a white space. So we see that the exclamation marks and the commas still remain part of the field. So again, if the field is Thundercats with the exclamation mark, change it to Lightning Cats with an exclamation mark, and then return it. So we'll do some extra modifications. So we're saying use the NR, so the line number, put a period, add a space, and then output the rest of the line. And then when we get to the action part of it, we're saying print, and then we call the function we just defined up here, and then we pass in whatever we're passing in. So we passed in as our parameter the entire record. So we're saying $0, remember, because that means the entire record, and we pass that in as our parameter. So when we get back in our terminal, because we said print, we see the numbered rows, remember NR and then a period, and then we look for uppercase Thundercats. So we see Lightning Cats, and then also here. But again, these two, because they have exclamation marks, would have failed to change because if only we had this. But because we have this extra conditional, we are also accounting for that. So there are easier ways to do this. So like I could have done this much faster using sed, but this is just to show you how you can use an UDF and a for loop, a while loop, a do while loop. You can do pretty much very robust things using these UDFs in awk. So it's a very robust tool that we recommend you learn.
Here's a stupid question. So why wouldn't we do this in like Python or Java? Like what's the benefit of using awk versus just hacking something out in any of the 90 different programming languages?
I can't speak on Python as much, but from what I understand about Java and like Scala or something, it's just faster. It's way faster. And you can do things in one line versus writing out necessarily a full program to do something and then potentially packaging it, then running it. Whereas this, it's most tools are already in your command line. Or depending on your OS, you may need to download it. But again, because it's command line tool and because of how awk and sed work, you can pick it up and put it anywhere you need. So this is kind of tabular in the format. So you can put it in the pipeline. So if you're moving data from a source to a destination in a giant ETL framework, you can plug and play this wherever you need to do your transformations as necessary.
Yeah, I think even it's probably faster than Python at some stage, because it's written in C or C++. It's going to be a lot faster. I think the major drawback is probably like, can you do any type of calculation inside these scripts?
Yes, to an extent. So we'll cover that in the extended part of the demo. But I haven't done any like significant calculations, but they have functions that we used. So like the mk time function calculates time in seconds using whatever integer, and then we do round functions on that to get a nice whole round number. You can do counts and other, they might have other math operator functions. I just don't know because there's a ton. But yeah, it's probably in the documentation somewhere.
Cool.
Yeah. Okay. So we will now show you how to write files. So this we said print, and so it printed to the terminal. But say if we want to write this output to a new file. So all we need to do is run the same exact function or same exact command. And at the end, write an open caret and then whatever our output destination file is. Excuse me. So if we say awk flag f script.awk and then our input file, and then with this second part, we're saying write it to a file called substituted.txt. And then if we just run a quick cat on that, we can see that it comes back the same as our input or like the original without the actual writing to a file. So if you want to write something and end your pipe or end your single command there, that's just a quick way to do it. So as I mentioned, we can use sed for certain things as well. So instead of having that additional condition in there, we can do all of this in one line without the script. So what we're saying here is we're saying awk, and then within our program, we're saying we're keeping that same print. So we're saying print the number line, period. So 1.0, 2.0, et cetera, and then print that specific line from the lyrics.txt file, and then pipe it into sed, and then using sed, do a substitution on Thundercats for Lightning Cats. And again, because we're not using that for loop, this is just a faster way of doing it. And then we're still writing it to a new file. So it's the same format. So a lot of things that you'll notice if you're working with like sed and awk, you can do similar things. Obviously awk's a little bit more powerful, but there are things in sed that you can do faster than you can in awk. So it might be worth it just to do something in awk, pipe it to sed, pipe it back to awk. But essentially, if I just cat this sed.txt, it's the same. So without having the script file, we were able to do the same exact thing we did with using awk and sed in combination of just versus just using awk. But yeah, we will now move on to a real world example, quote unquote. So what we'll do is kind of just go over the scenario, or actually I'll pause here to see if anyone has any questions, or if I've gone through something that someone wants to add to, feel free.
I think you can go ahead, Arpan.
Okay, so let's introduce this real world quote unquote example. JB, yes, this works. It's a command line tool, so it should work on depending on your OS. I think there is a Windows version.
Well,
that-
Windows 10 has
Yeah,
Ubuntu
and
now, so
Linux, yeah. with
there's
the-
also Bash for Windows. So yeah, it should be there.
yeah. Okay, yeah. So back to this real world example. So say someone on our team or someone in our company hands us a CSV file. They notice that the first field is missing a value for at least one row, and they're not really sure how many other rows are affected. So they want us to look at it. So how can we approach this with something like awk? The first thing we can do, not necessarily with awk, but just a quick grep. So just another command line tool that can make your life a lot easier. We're just going to run a quick grep on the file to see how many rows are affected. And our CSV is called spacecraft journey catalog. So essentially it's a summary of a spacecraft flight, journey ID associated with it, a end time and a start time. And we'll cover the end time and start time in the extension part. But for now, we'll just cover on how to do some data manipulations and transformations, cleaning, et cetera, et cetera, et cetera. So we see that within this spacecraft journey catalog CSV that our team member handed to us, we see that there's at least like 10 records that are kind of, so we need to do something about it. So the first thing we can do is we can create a file with these specific records that are affected and essentially isolate them so they know what's wrong, where it's wrong, et cetera, et cetera, et cetera. So we'll be using a couple of different operators and built-in variables in this example. So we'll be using an option called flag capital F. So Mark, as you mentioned, we can choose what we want to set the delimiter as. So when you use a capital F, that's the field separator. So we say capital F and then just whatever character or characters you want. So for us, because we're working with CSV, we'll say capital F and then a comma. And then we'll also use a begin. So the thing about awk, the structure of how you can create a program is you can have a begin statement, other rules, and then you can have an end statement. So the begin statement is only read once. The end statement is also only read once. So if you want to define something or say something and only have it read once, that's where you would put it. So usually if you're like setting rules or variables, like global variables within your program, you would just put it in your begin and they can be accessed in the rest of like while the program's running through your file. And then the end, so if you want to put like a footer on something or some text or whatever, or just in general, you only want it at the very end of your output, that's where you can put it. And then we'll also be using OFS. So OFS is the output field separator. So it's different from the input field separator. It's the output field separator. So after awk does its programming, when it puts the output, it uses this character as the output field separator. And so awk defaults as a white space as the field separator. So if we're using this command, so I'll actually show you what it looks like when we're not using the OFS as a comma. So if we're working with CSV, set the field separator as a comma, and then the output field separator as a comma. And we'll show you what it looks like without it. All right. So what we're doing here is we're saying awk, capital F, field separator option, and then comma, because that's our field separator. And then within our program, we're saying begin, and then we're saying the built-in variable OFS, so our output field separator is going to be a comma. And then we're going to look for a pattern. So a caret, so like an uppercase caret, means at the beginning of a line with the comma. So this is our pattern. And then this is our action we're running on it. So if at the beginning of a line, it's empty and just a comma, change the first field to missing summary. And then when you have a semicolon, that's when you can have multi-actions. So we're just saying, do this action, and then also print that line. And then do it from the input file, and then export it as corrupted.csv. So now when we cat corrupted rows.csv, we see, okay, we see instead of having, oh, we don't have it anymore, but instead of having just a blank first field, we have this essentially just saying this item is missing a summary. And then we still have the journey ID, and then we still have the end time and then the start time. So as I mentioned, if we rerun this line, so I'm just going to change this to corrupted rows 2. And then if we remove the output field separator, remember it defaults as a white space. So if we want to keep the CSV format, we see how the difference. So the output's not actually putting it back into CSV format. We have to specifically say, use a comma as the field separator for the output. So if you use this and give it back to them and they try to use it, potentially put it somewhere else in a database, et cetera, they might have some issues, or they may need to manually do something about it. So just using this little bit of OFS just makes everyone's life a little bit easier. It's a pretty simple variable to pick up, and it's defined in their documentation, just also online, but a bunch of resources will be available in the blog post that goes up with this. And it'll also be available in the slide deck when it goes up. But yeah, so that's how we were able to create a corrupted rows CSV, keep it formatted in CSV format, and just, we could take that and hand it off to someone. But say we could also do the same exact thing, but what we can do is we can say, okay, keep all the records, but then just update the specific records that are affected as a stopgap. And so how can we do that? So what I'll do here is I'll just talk through the command first, and then we'll look at the script file. So we're saying awk, capital F, field separator. So our field separator is a comma. Lowercase f is the file. We're using a file, and we're using a stopgap.awk excuse me, and then our input file, so our source that our team member gave to us, and then we're pushing it to stopgap.csv. So if we look at the stopgap.awk file, so essentially what we're doing is we're running another UDF. So we're saying function substitute, take the input of CSV, so whatever our $0. So when we call it here, we're saying if the length of the first field is equal to 0, make the first field say missing summary. And that's it. And then return everything. So we're returning every line and not just only the affected items. So again, we're saying begin OFS. Oh, and as I mentioned, remember how we talked about earlier, if you're using a script file, you don't need the single quotes around everything. But essentially what we're saying is, again, the output field separator is going to be a comma, so we can keep it in CSV format. So if we didn't have this in this specific example, everything else would still be in CSV format, but the 10 or 14 affected rows would have a white space instead of a comma. So it would cause a file issue if you're trying to import it somewhere. But yeah, so that takes the OFS comma takes care of that. And then we're just saying print the substitute function, and then take the everything and plug it into that function. So if we look at stopgap.csv, if it loads, so this CSV is about 1,000 records. So it was able to do it like that. Just another reason to use something like this is where you can operate on a good amount of data really fast. But essentially, if we just do a quick search for missing summary, so we see that we have a stopgap words. We've kept the corrupted rows, but we just said something to notify or like indicate that it's a malformed data piece. But yeah, so if we look back at the original CSV, so the spacecraft journey catalog, we see that it's 1,001 row because we have the header. But yeah, so we still maintained everything with just only addressing the items that needed data cleaning. All right, so now we'll talk about the extension. So this one, say that team member that gave us the initial CSV files, like, but wait, that's not all. Can you also do some data calculations and do some data reformatting? So essentially, if you remember, the initial CSV has a summary, a journey ID, an end time, and start time. So if we look at the format of the start time and end time, we see that there's additional items on it. So for us, we can think through this in steps. So if we want to use the function, like I mentioned earlier, the MK time function, which calculates the time in seconds, we need to have a very specific format. So it needs to be year, white space, month, white space, day, white space, hour, et cetera, from year to seconds. So essentially it's each block of time separated by a white space. But if we look at our data here, we have dashes and we have colons, but we only want data up to here. So how can we address this? And then after that, we have this, we say we've already made this data change. How can we use awk to get rid of these and do conversions to get rid of the dashes and the et cetera? And then if we want to calculate the time, we can just subtract the seconds that were calculated from the end time and the start time, and then divide that with some, I think it's what, 86,000 seconds, because if you just do some quick dimensional analysis or a quick Google search, then there's like 86,400 seconds in a day. And then we'll eventually calculate the duration of a flight in days. And then we can then take the output of that. And then I'm just talking because I know the future a little bit, but essentially when that output comes out, we notice that the header is not actually what we want. So the header remains summary journey ID, but the end time and start time have some errors in it, or it doesn't actually do what we want it to do. So what we can do is run a set replace on it and just say, take the header that's already there and then put the header we want in. So I'll go ahead and run the command, or the pipe actually, and we'll talk through the steps again, a little bit more clarity. But essentially what we're doing here is we're saying sed substitute, because again, remember, we only want this part of the date time to fit the make time function format. So we want to get rid of this period and everything else. And if you just do some quick data analyzing, you'll see that it's pretty much the same for every record for this specific example. So we can say, look for this pattern, and then essentially just delete it and then do that globally, because we instead, when you have a substitution, it only works for the first occurrence. So if you want it to happen for every occurrence in a line, you have to use the global option. So we're just saying, because it happens twice, because there's a start time and an end time, we need to do it globally per line. So we're saying, okay, so delete this part of the date time from the stopgap CSV, and then run an awk script, file separator, comma, to calculate the duration in days, and then fix the header. So look for the bad header that comes out of awk, and then update it to the header we want, and then write it to a new CSV. So if we go into duration calc awk, so what we're saying here in the programmers, we're saying begin OFS. So again, to keep everything in CSV format, the output, we run gsub. So it's a function of awk where it's essentially doing substitution. So we're saying take hyphens and colons, substitute it with a white space for field number 3. So field number 3 is when you use the file separator, comma, so the capital F, comma, we're saying field 1 is the first field, or column 1 is field 1, column 2 is field 2, column 3 is field 3, column 4 is field 4. So that's how we know off the bat, okay, our end time, we already know is field 3, right? Because we were saying that's the comma or the field separator, and we can just do some quick knowledge. And then we're doing the same thing again for field 4. And then we're using this make time function. So we're saying D2 is equal to, or is D2 is the same thing as end time. So we're saying $3. So calculate the duration in seconds of the end time, calculate the duration of the start time in seconds, and then we're printing field 1, which is column 1, printing field 2, which is column 2, so the summary and the journey ID, because again, we're still keeping those columns. We're just calculating the duration in days of the end time and start time. And then we say, I'll talk about the round function in a second, but we'll say subtract the start time from the end time, and then divide that by the number of seconds in days. So that'll give us a duration in days. And then because that gives us back a floating number with decimals, we need to use a round function. So GNU's documentation has this round function for you. You can just copy and paste it in. But essentially, when we finish running this, and then we do the third part of the pipe, which is the second sed, which fixes the header. And then if we go into duration by journey summary, if we scroll down, we still have 1,001 records. We updated our header to what we actually want. So the summary, journey ID, duration in days, because we used field separator 1, field separator 2, and then the third column would be, or like the third item output would be the duration calculated. So we have these nice whole numbers. We have 8, 160, 4, 161, 23, etc. So we used awk to do, or awk and sed to do data cleaning, data transformation, data processing, et cetera, and calculations, and outputted a whole new CSV that someone can take right now and create a new table in their database using this new information. Or they can take this and put it in a BI tool somewhere and say, hey, run some analytics on this and see, okay, what's taking this specific type of journey. So like, say if there's multiple journeys that have the summary of bring supplies to a space center, but they have various different durations and days, you can use BI analysis and your team's data analyst could be like, oh wait, there's something wrong here. So if there's like a really weird outlier or really off, like your regression is off, or your not regression, but your just in general your median or your bell curve is very skewed, you can see that what's happening and you can make data driven decisions that we've given someone and done very quickly. They can take it and make modifications on what someone's doing. Maybe the pilot had a bad day. It just took very long to do something, or there was some kind of thruster issue. But yeah, essentially, we were able to use a tool like awk or a tool like SED to do very fast, and on 1,000 rows, it literally happened in a second. And this was on a Gitpod container. Like this is even on the powerful machine. But yeah, that just shows you the power of how you can use something like awk and how you can use something like SED to do data transformations, data processing in your ETL pipeline. Because like in this one, we used an input from a C file, and then the second part of our pipe was, and then our third part of our pipe was SED again, and then we wrote it into a new file, and then we handed it to someone. So everything we did, granted, we had one script file, but everything we did was in one command. That will wrap up our walkthrough on awk operations. Like granted, there might be faster ways to do things that I did, but again, this is just mainly so that you can get a basic understanding of it. And so that way you can try your own hand at it, get better at it, etc. That's all it for me.
Awesome. Thank you, Arpan. Yeah, we're almost out of time. Very powerful. I was just thinking while you were doing this very last operations, like, probably stand up some microservices that basically clean data using awk and SED. Probably scale better than some of the crap people write in Java. So no, it's really good. Thank you so much. Good stuff, Arpan. Folks, thanks for joining us today. Same place, same time next week. Going to continue on the data engineering journey. As you know, we're always looking for speakers, and if there's not a speaker, we just pick something off of our data engineering guide. We're walking through programming languages, scripting languages, databases, scheduling, DevOps, data ops, new stuff. And the goal is that as we go throughout the whole itinerary of the year, we'll have covered everything in the data engineering guide. Looking forward to seeing exciting presentations from all of you. And then in general, just building a library so that somebody can just walk through and watch all these videos and learn data engineering. Speaking of which, everything that at least we produce on Data Engineers Lunch gets blogged about on blog.anant.us. And all of this stuff also gets put onto YouTube. So the last 16 or the last 15 Data Engineers Lunches are all on YouTube, or should be. So thanks a lot, Arpan. Great work. And I'll see all of you next week, same time. All right, noon on Mondays. Take care. Bye-bye.